So now we want to look at factorizing difference of two squares. What do we mean by difference of two squares? First, there must be a difference. Difference means we subtract. And then secondly, must be two square numbers. So, for example, x squared, remember x is a number, right? X squared, and then another square number. We know what the square numbers are. 1, 4, 9, 7. No, sorry. Is 7 a square number? No, it is not. What do you square to get 7? There's no whole number that you can square to get 7. So a difference of square would be maybe a number like 9 or 16 or 25 or such numbers. Alright, so difference of two squares. So the x squared and then 16 can be written as 4 squared. So there's a difference and then we have two squares. And we have a basic rule for that. So this is x minus 4, x plus 4. Another way to look at it, if you remember when we were factorizing the quadratic, this is a quadratic, but remember there's no b value. There's no middle value. It's just the x squared term and the constant. And if you want to think of two numbers that add to give the b value, in this case the b value is what? 0. And of course the two values must multiply to give AC. And what is AC? Just the same method. AC is 1 times minus 16. So AC is minus 16. So you need these two numbers. What numbers multiply to give 16? 16 and 1, and 4 and 4. And obviously, one of them has to be positive and one negative, because when you add them, you need to get 0. Good. So as a general rule, for difference of squares, alright, a squared minus b squared is a minus b bracket a plus b, and by far is the easiest type of factorization. Let's look at a few more examples. So factorize p squared minus 36. Of course, the difference of squares because it's a difference, it's a negative, and then 36 is a square number, since 36 can be written as 6 squared. So there we have a difference of squares. Alright, so we form our brackets here. And we have p, and we have p. And we think of the two numbers that multiply to give negative 36 and add to give 0. And of course, we just use these values. Alright, positive 6 and negative 6. Doesn't matter which value we put in front. Whether it's p minus 6 or p plus 6, same result. Let's look at another one. Suppose we have something like 4x squared minus 1. Both of these can be written as squares. So 4x squared, that can be written as 2x all squared. And of course, 1 is 1 squared. And therefore, we have 2x, and we have negative 1, and we have 2x again, and we have positive 1. Notice the pattern, the same items in the bracket except one is positive and one is negative. Let's look at another one. 1 minus 9h squared. Of course, we can rewrite both of these terms as squares. So 1 is 1 squared, and 9h squared. How can we rewrite 9h squared? It's 3h all squared. So in our brackets, we'll have 1 minus 3h and 1 plus 3h. Let's look at another one. Suppose we have double square minus 4n square. Is that a difference of squares problem? It sure is. We have double square and we have 4n square can be written as 2n all square, and therefore now 4 more brackets. And what we have square now? We have W minus 2n, and we have W plus 2n. Now here's another factorization problem. Notice this has a highest common factor. There's a common factor here. So 4 and 16, right? So 4 is obviously a common factor, so we can factor out the 4. If we factor out the 4, to get the remaining terms inside the bracket, we can divide each of these terms by 4. So we factor out 4. 4 into itself, that's 1, so 1x squared. And minus 16 over 4, that's minus 4. Now, is that factorization complete? We should be able to recognize that what you actually have in the bracket is a difference of squares situation here. Because this is x squared, and then 4 can be rewritten as 2 squared. And so, the difference of squares problem, so we keep the 4. Can't throw it away, you have to still put it there. And we factorize x squared minus 2 squared as x minus 2, x plus 2. And we are done. Another one, 16 minus x squared. 16 can be rewritten as 4 squared. So it's 4 squared minus x squared. And therefore, what happens now? 4 minus x, 4 plus x. So by far, the easiest type of factorization. Let's look at another one. 2x squared minus 50. Of course, this has a common factor of 2. So we factor out 2 first thing. But when we factor out 2, remember, you need the terms for the bracket. So we get the term by dividing these by whatever we factored out. So 2 into 2, that's 1. So 1x squared. And minus 50 divided by 2, that's minus 25. Now, is the factorization complete? It's definitely not complete, since we should be able to recognize that we have a difference of squares situation inside of the bracket here, because 25 can be rewritten as 5 squared. So hence 2, and we factorize that as x minus 5, x plus 5. There's another one. So we have to ask ourselves, can these terms be written as squares? Yes. 25y squared, that's 5y times 5y, right? And then 16r squared, that's 4r times 4r. So these terms can be written as squares, and hence can be factorized as a difference of squares. So 2 brackets, notice the same term, so 5y minus 4, and also 5y and 4, but this time this 5y plus 4.